Now, we will continue with our next speaker, Mr. Matthew Geraghty. Hello, Matthew. Welcome. Matthew is an engineer at DNV, working within the Renewables Project Department with a focus on offshore wind due diligence. He has a background in project development and energy yield analysis, having previously worked with one of the world's leading renewables developers. For the past year, Matthew has been leading DNV's innovation efforts with regard to onshore wind decommissioning and recycling, and has recently launched DNV's new Rewind service. Matthew, where hear you?
Thank you very much. And thanks for organizing this session. It's excellent. So yes, as I said, my name is Matthew. I'm from DNV. For those of you that don't know, DNV, we're a worldwide consultancy with a very strong footprint in renewables, and we've got a strong presence in Greece and across the rest of Europe. And I'm here today to talk to you about Rewind, which is our new innovation project, which hopes to focus on accelerating sustainability in decommissioning. By the end of this presentation, I hope that everybody here, as stakeholders in wind projects, will know what they can do today to make sure that decommissioning is handled in a sustainable manner. So I'm going to start with a question, just to put some context on this. Why should I recycle my wind farm components? Some people say it's too expensive. Some people say it's too difficult. But I'm here to tell you that it's neither of those things. It can be done efficiently, and in fact, it needs to be done efficiently. When you look at the context in Europe at the moment, as mentioned earlier, there are over 20,000 turbines that are over 15 years old or more in Europe right now. That's expected to generate over 30,000 tons of waste by 2025. And Greece, as one of the early adopters of wind energy, is one of the countries that's going to have to face this problem head on. We also know that Wind Europe called for a ban on the use of landfill last year for all turbine components. And as mentioned before, there's already a number of countries such as Germany and Finland which have already adopted this and enacted it into law. And we're expecting that to be rolled out across the rest of Europe. On top of this, the new EU taxonomy was launched in January of this year. People ask, well, what is the new EU taxonomy? How does it affect me? Essentially, the EU taxonomy is a classification system establishing a list of environmentally sustainable economic activities. So if you want your project to be considered economically sustainable, then you need to show that you are doing no significant harm and meeting these criteria. And that includes managing your waste and end of life. So that's just a bit of background. Now, the central question to this presentation is, what do I need to do to make sure my wind farm is sustainably decommissioned? The first things first, make a decommissioning plan. Every owner and stakeholder in a wind project should be making a decommissioning plan, and we recommend this is made at least 5 years in advance of the end of project life. If this is done, it means you can take into account the various different options, life extension, repowering. And you can also better estimate your costs and estimate the effort that's going to be required at the time, so you don't end up in a situation where you end up spending more than you should at the end of a project life due to lack of planning. On top of this, there's also other things that we should consider. And even at the start of a project's life, we'd recommend considering your end-of-life plan. Environmental and social governance, or ESG as it's called, is becoming more and more popular. And as mentioned with that EU taxonomy, if you want to be considered a sustainable investment, you really need to be considering what you're doing with the materials at the end of the life before you even build that project. The best way to prevent waste is to incorporate that at the design stage. Now, well, what can you do today? The first thing you can do is you can answer 3 simple questions. And we're going to focus on these questions throughout the presentation. First of all, well, what materials will I encounter? What regulations do I need to follow when handling those materials? And then the third thing is, well, how much is this going to cost? So let's take a look at those. Starting off with what materials am I going to encounter? And it's not just what materials, it's how much of each of these materials as well. On the right, you'll see a table that we put together for a completely fictional turbine that we've made up. We can do this for any turbine. And we want to work out exactly what the weights are and what the material composition is of each of these components. It's essential to know this information when planning a decommissioning project. The reason being, you can accurately plan for the equipment you're going to need, bigger, smaller cranes, whether you're going to need different machinery for maybe cutting up blades while sending it to recycling facilities, but then also to estimate the value of that scrap material. And that's really where value can be found in these decommissioning projects. Also, we want to try and identify if there's any potential harmful or hazardous materials. These materials are very small and very rare in wind turbines, but things like oil in gearboxes need to be handled in specific ways. And if you can plan for this, you can ensure that your decommissioning process is as efficient and low cost as possible. I just wanted to note one point, that there is a lack of data on the materials in turbines. Most turbines that are reaching 24, 25 years old at the moment were from an age where this kind of information wasn't digitalized. So it can often be hard to find out this information. And even for newer turbines, this kind of specification isn't part of a normal turbine supply agreement package. But luckily, we are able to model these. We can look at the dimensions of turbines and we can work out what materials we expect to encounter. And this can really help to plan that decommissioning process better. I just wanted to take a special mention on blades. The guys from Vestas and Jonas at Siemens can tell you more than I can about this. But we need to understand, well, what kind of materials are we going to encounter in blades as well, whether it's going to be those glass fibers or epoxy resin. There's also balsa wood, which has its own issues in terms of supply chain. There's also carbon fiber and laminates, obviously, and then those adhesives and exterior gel coats. And really the core of what makes recycling composites difficult is trying to separate these materials from each other. But I mean, it's not all doom and gloom. We can do things with these. As mentioned at the start of this session, 85 to 90% of wind turbines' mass can be easily recycled. They're metals, aluminium, copper, steel that can be easily recycled and easily turned into a net benefit for your project. But then blades, as mentioned, are the more difficult issue here. Cement co-processing has been talked about, advanced grinding techniques where we can try and get really fine material that can be used as a virgin feedstock. But then also there's that reuse case. Pictured on the right here was the world's first bridge made using a turbine blade as a structural component. There's another in Cork, close to my hometown in Ireland, which is currently in construction and I think is due to be commissioned this month. And it's this and playgrounds and bike shelters that we've seen before that are something we can do right now to help address that need for use of these old blades. I also wanted to give a special mention to rare earth materials, rare earth metals, sorry. These are common in today's turbines and maybe not so much in some of the much older turbines. But there's a big push in Europe to try and keep rare earth metals in Europe. At the moment, a lot of rare earth metals are shipped to China for processing and sent back, and that has its own supply chain issues. When planning a decommissioning process, if we can keep rare earth metals in Europe, it makes a huge difference to both the carbon footprint of these projects, but also that supply chain for future projects in Europe as well. So now we know what the materials are. Secondly, well, what regulations do I need to follow when handling these materials? It's all well and good knowing what you have, but then you need to know, what can I do with these? So there's two main points here. So there'll be your permit requirements. So any wind project, when it's built, will have some kind of planning permission, will have some kind of building permit. And usually in a building permit, there will be a kind of standard condition that says we need to return the site to its original form. But in some instances, we've seen countries enacting laws that go beyond that. For example, for the first time this year in Sweden, we've seen projects where mandatory recycling of all turbine components has been included. And secondly, also in South Africa, in order to obtain a building permit, you need to submit a decommissioning cost study to prove that funds will be set aside to deal with the decommissioning of the turbines when it comes into practice, which further shows just why we need to recycle. This isn't becoming an option, and we expect this to be rolled out across Europe, and more, simply landfilling blades is not going to be an option. So second, and where that ban on landfill comes in, is on those waste disposal laws and guidelines. So in Europe, there's two stages. There are EU directives that set out the framework for these laws, and then they pass into national law. This next table is just a quick highlight of each of these laws. I don't expect anyone to dive into too much detail here, but basically there are certain legislation, like at least 70% of the weight of all construction concrete needs to be recycled, or looking at metals, 100% of your metals should be recycled. And there's various different laws that kind of evolve over time. But the goal should not be just to meet these minimum standards. The goal should be to try and align with best practices and make sure that you're trying to make a positive impact on the environment, but also on the image of our wind industry. We spoke about the EU taxonomy earlier. So in order to be compliant with the new EU taxonomy, you need to show that you are doing no significant harm, But on top of that, you could also show that you're providing a net benefit. And projects such as the one shown on the right here, where a playground has been built, is also a huge opportunity for stakeholders in wind farms and owners of wind farms to put a positive spin on end of life for the wind industry and to really garner more attention and maybe even garner more investment in their projects going forward. Sustainable companies are the future at the moment. And if you can show off that you are sustainable, it's bound to benefit you in the long run. So that's how we deal with these materials and what we should be striving to in terms of rules that we need to follow. The third then, and this is probably the most hot topic for everybody, is how much this is going to cost. This is the question everybody asks. Is it not going to be very expensive? Well, first of all, why would we estimate those costs? As mentioned, recycling is just going to be the norm. There's no way this is not going to be an option. So we need to make sure that there's enough funds set aside for that. Also, it can be useful to estimate the cost of decommissioning and recycling to accurately value projects during transactions, if you're buying or selling projects, or even financing new projects or refinancing existing projects. And the other thing is when we look at companies' preferred actions, which are usually life extension or repowering, well, we forget that repowering also involves decommissioning the existing turbines. It involves taking down old machines, processing that material in some way. And accurately knowing what the cost for this is going to be can really help build that business case for repowering. So what do we need to consider? Firstly, we've got your disassembly and removal costs of turbines, of foundations, maybe roads. Also, you'll have some kind of overhead costs, project management. And then also there's that scrap value, that all-important scrap value that can be used to offset your decommissioning costs. Here, we just have a table of a fictional project. So before anybody goes screenshotting this is completely made up. I can't tell you that these costs are accurate for anything, but it's based on our experience. So we look down, we see we've got broken down into the various different disassembly, removal costs, reinstatement costs. This doesn't include any of your scrap benefit. And if we were to dive further, just let's focus on turbines for a second. Well, what we know about turbines is that we've got those disassembly costs and removal costs. And the big drivers on these are, well, what size of a crane do you need and how long do you need that crane for? How long is the project going to take? And then in terms of removal, it's how close are you to a recycling facility? So those kind of things that you need to think about when you're trying to estimate these costs, and trying to plan this decommissioning process as well as you can help to reduce these costs and make it more efficient. Then when we look at the scrap value, there is inherent value in metals, obviously, things like steel, your generators, copper, aluminium, but there's also value in scrap concrete as well. And one of the big question marks here and how you can actually try and drive your project away from being a cost is that blade cost. So blade disposal, what can we do with it? Is there a secondhand market for blades? Can we sell them on straight away? Do they just need to go to the landfill, which is obviously the worst option, not just for the environment, but also for your own wallet, for your own costs. If you're just throwing blades away, you're not getting the full benefit out of them. Cement co-processing, as we mentioned, is the most popular method at the moment that can be used, but also think about, can they be repurposed for those playgrounds, for those climbing walls, and could there be some kind of benefit in it for you? Could one of these companies be willing to pay you to take away those blades? And then also we have these new novel recycling methods. Just from our own experience, if we want to see that decommissioning cost going from being a net cost to a net benefit for your project, the only way we see this as possible right now today is through that secondhand market option. So we know in Europe there's a vibrant market for secondhand turbines, for secondhand components, and if you can really make sure that can happen, and that comes with advanced planning, you can actually try and turn your net cost into a benefit. So hopefully we've answered all those questions now. Just a very quick note on what DNV can do to help. So basically everything you've seen in this presentation before, all those tables, pictures, they all come from our reports from this new Rewind service. We've just launched this new Rewind turbine recyclability service a couple of weeks ago. We've already had a couple of projects we've completed. Basically, what this report does, if you want to get involved in one of these reports, is that it'll provide those turbine materials and weights. It'll give you the applicable recycling methods for each of those. It'll show you what the permit requirements are and what the waste regulations are, exactly where you are based. And that's really important because that varies hugely from country to country. Provides you with those decommissioning cost assumptions and also provide recommended actions that you as stakeholders in a wind project can take right now to make sure that end of life is approached in a sustainable manner. So if this is of interest to you, please reach out to us, reach out to our team in Greece. Volantis' email is below. There's a QR code that you can scan, take you right to our website where you can get involved straight away. And we'd love to take any questions now. Thank you very much.
Thank you very much, Matthew. Now